what all the things in this do. So again, nets are when you take a shape like this and you visualize, what does it look like when you look at it straight on, or right from the top down, or from the side, left or the right or the back, and what do these actual shapes look like? Um, and this kind of graph paper is really fun because you can take this shape and you can sort of spin it in your head and see it from slightly different angles. So I've done it in a couple different angles. If you want to play with this, by all means play with this. But really what we're going to do is we're going to concentrate on the lesson at hand. Before I get going here, I don't want to see that, but I do want to see this one. So just to let you know, tomorrow morning at the same time at 10 in the morning, I'm going to have an extra math session, LlamaMath extra session for the catch up. So if you didn't get part of chapter 2 and you got a terrible mark and you want to figure that out and redo it, then absolutely you can come into my overtime session. It's going to be tomorrow, the 22nd at 10 o'clock, and log in, ask me any kinds of questions about any of the material that we've gone over. If you're having troubles with the volume or the area or any of the tests, or if you want to redo a test, it's like, yeah, I just didn't get this concept. Can you show it to me again? And absolutely, this is what it's all about, is for me to go over that. I might offer one in a week, but I'd much rather have it just one shot tomorrow at 10 o'clock. Okay, so this week, again, what we're going to do is we're going to be talking about rates at the start, and then area, volume, and nets if you want to at the very end. The first page is essentially all formulas, and these are formulas to figure out the area of a triangle, a rectangle, a circle. These are important things to know in life. And then also to figure out volume, and there's a real trick to some of these. I put in a sphere just because I think it's cool. It reminds me of the Death Star. And also pyramids and circular cones. Not often you're going to have to do that. And if you do have to do that, you're going to look up the formula. So I don't expect anyone to really memorize these. It's good to memorize these ones, but these ones you don't have to memorize. You just look it up in a book, but I do want you to know how to apply them. Anyways, without further ado, here we go. So page 2 of the notes. We're going to talk about unit rates. Zoom in here. So a unit rate is a ratio, it's supposed to be, I'm going to erase that, a ratio or a fraction that compares some amount of units of one quantity to one single unit of another quantity. You're going to say, what the heck are you talking about? So what I'm going to talk about is things like 30 kilometers per hour. Kilometers and hours don't really mix, but you can put these in. We are traveling 30 kilometers in 1 hour or per hour. Or in the record player, it's 33.5 revolutions per minute, RPMs, or 5 hot dogs per minute, but you recognize that the last number here is always per 1 hour or per 1 minute or per 1 minute. These are things that we see all the time, and we're going to talk a little bit about these and how we can play with them a little bit. I just want to make sure everyone's added. Perfect. So the denominator is expressed, the bottom number is expressed as a single unit. So it'll be 1 hour, and we can often rewrite this as a division. And I'm going to show you in how we can deal with that. So in real life, we don't often measure things exactly in 1 hour or 1 day or 1 minute. Here's a good example. What if it takes us 6 hours of driving to cover 580 kilometers? So we had 580 kilometer distance to drive to, and it took us 6 hours. How fast were we going on average? So how fast is in kilometers per hour? I'm just going to make my pen this. So the first thing that I'm going to do is I'm going to state what I want. So I'm going to write, let me just change this to red, and then that will make a lot more sense to me. I like that color, perfect. So I'm going to state what I want. I want kilometers per hour. Second thing is we're going to find in our word problem, where's the kilometers part? This is what we want on the top. Oops. Oh, wow, I'm having real difficulties this morning. All right, here we go. So the first thing I'm going to do is, because kilometers on the top, I'm going to find out how many kilometers are in our example. Well, we're driving 580 kilometers. So I'm going to put that on the top of the fraction. And I'm also going to put the unit here. And then, of course, on the bottom of this fraction, our dividing is here, we're going to have the hours. How many hours did it take? It took 6 hours. So I'm going to put 6 hours on the bottom. So I have 580 kilometers divided by 6 hours. And in your calculator, you're going to do that. You're going to type in 580 divided by 6. And it gives you 95 kilometers on the top of the unit per hour on the bottom. And there we go. We got our answer. All right, I'm going to give you another example for Canucks dealing with all their problems recently. So another example is, in the last 5 games, the Canucks captain had to serve 28 penalty minutes. What was his average penalty minutes per game? So what are we looking for? That's the first thing I want to know, is what are we looking for? We're looking for penalty minutes per game. So I'm going to write that, penalty minutes per, which is the dividing line, game. And then I'm going to start filling it in. Okay, how many penalty minutes are we talking about? We're talking about 28. So I'm going to replace the top with 28. And I'm also going to put in the unit, or whatever I'm looking for. So penalty minutes. And on the bottom, I'm going to have games. And it's 5 games. So I'm going to put 5 on the bottom. So this is like 28 over 5 as a fraction, or as a division, it's 28 divided by 5. And so when I do that in my calculator, I get 5.6 penalty minutes per game. Pretty simple stuff, right? All right, let's move on to page number 3. And we will get to practice these in just a moment. So one of the other really cool things that you can learn, and it doesn't take that much, is converting between units. This is going to be the headiest part of the presentation today. Remember that that rule from fractions, where you can multiply a fraction as long as you multiply the top and the bottom by the same thing. So we remember that, right? If we had 2/4, we can multiply by 3 on the top and the bottom. And on the top, that would give us 6, and on the bottom, that would give us 12. And 2/4 is the same thing as 6/12. So we're going to sort of use that rule, but in a slightly tweaked way. And they don't really teach much of this in high school or in middle school. So this is a great skill to know, because you will have to do this in science a ton, and probably in math questions too. So this is a great idea. So consider this. 1 minute is the same thing as 60 seconds. So instead of multiplying by 3 and 3, I'm going to do, like, I could multiply by 1 minute over 60 seconds. They're the same on the top and the bottom. The same as 3 and 3 are the same. 1 minute is the same as 60 seconds. Or you can flip it around. You can say 60 seconds is the same over 1 minute. It's just the same thing. So I'm multiplying by 1. Or, you know, if, for instance, 24 hours is equal to 1 day. So I could multiply something by 1 day over 24 hours, or 24 hours over 1 day. The same thing, really. And because 1 day is 24 hours, or 24 hours is 1 day, I can do this. So I'm going to show you how we can use this, and it's such a good skill to have later on in your math career. So if I can perform 4 multiplications each minute in my head, so you're going to give me 2 numbers times 2 numbers, and you're giving me a whole page of them, and I'm going to race through, and you're going to give me multiple pages of them. If I can do 4 a minute, how many can I do in 1 hour? So what I'm going to do is, I'm going to, first of all, I just want to say that 60 minutes is equal to 1 hour. And of course we know that. So the first thing I want to do is, how many could I perform in 1 hour? So what am I looking for? I'm looking for calculations per hour. So I'm going to write that. What are the units that I want in the end? Calculations per hour. So then what I'm going to do is, I'm going to replace what I know. Well, I know that for calculations, well, that's my 4, so I'm going to put that on the top of my fraction. in calculations or multiplications. But this is each minute. So I'm going to say in 4 calculations per 1 minute. But I want it in hours. I want calculations per hour. So what can I do? Well, let's go back to this rule where I can multiply the top and the bottom by the same number. But instead of the same number, it's the same value. So what I'm going to do is, because I have minutes on the top, I want minutes, because I have minutes on the bottom here, I'm going to want to multiply it by minutes on the top here so that they cancel. The bottom cancels out the top. And I'm going to show you that. So again, I'm going to multiply by 60 minutes is the same thing as 1 hour. And then when I get to this stage, I'm going to look and I'm going to say, okay, minutes cancels out with minutes. And if I multiply this through, it's going to be 4 times 60, which is 240 calculations on the top per 1 times 1 hour, calculations per hour. You see how it just sort of magically fixes itself. As long as I can cancel out these units, I have calculations per hour. We're going to do a few more of these examples so it'll make sense. And I apologize to the folks that I'm leaving in the waiting room. I'm trying to concentrate on the lesson too. Okay. Let's do some examples here. How many times does our heart beat every day? Any guesses? Is it like 1 million? Is it 1,000? Is it 10,000? I don't know. We're going to find out. Let's assume that and this is something that I would do in class, but I'd say, okay, everyone take your pulse and I want you to figure out your answer. Let's assume that it beats at 65 beats per minute. We're all pretty relaxed. We're all fit and healthy. Yeah, 10 million, who knows? We'll see. So what I want to do is I'm going to write down, what do we want? How many times does a heart beat every day? Let's do that question first. So I'm going to write the units that I want. I want beats per day. Okay, so I'm going to say how many beats? There's 65 beats per minute. Ah, well, I want days. So what do I multiply this by? I know that 1 minute equals, 60 minutes is 1 hour, and 24 hours is 1 day. So I'm going to use these. Because minutes are on the bottom, I want to multiply some where minutes are on the top so I can cancel these. Well, I know that 60 minutes is 1 hour, so I'm going to fill that in. 60 minutes is 1 hour. Okay, so when I do this, the minutes will cancel out, and I'm going to have 65 times 60 beats per hour. But I want to figure out per day, so I'm going to just do one more calculation. Because hour is on the bottom, I want hour on the top here. Oh, 24 hours is the same thing as 1 day. So I'm going to say 24 hours, same thing as 1 day. These units cancel out, hours and hours cancel. So now we're going to grab our calculator and we're going to go 65 times 60 times 24. And the units will be beats per day. And we have to divide by 1 and divide by 1. It doesn't change anything. So let's figure that out. 65 times 60 times 24. Okay, that's a big number actually. 93,600 beats per day. Now you guys are welcome to write this as like a sloped, like a slash. A slash is typically, you can use that as a fraction. If I really wanted to get geeky about it, I could do per day or per 1 day. Often it's just easier to say per day. We know that it all means the same thing. Okay, let's look at this one. How many times does it beat every year? Well, instead of redoing this and going from beats per minute and going all the way to year, let's just use this one. We know this is right. So 93,600 beats per, we don't have year, we have day, but at least it's a time. We want to multiply it where day is on the top and hopefully something closer to year is on the bottom, because we eventually want a year on the bottom. Well, we know that there's 365 days. Yes, there's 365.25, but whatever. 365 days is 1 year. So I'm going to multiply by 365 days per 1 year. My day units cancel out because the bottom and the top. You can't have bottom and bottom or top and top. They won't cancel out. But if you have a bottom and the top, they cancel out. So we have 93,600 beats times 365 times 365. Okay, this is a very large number. 3416400. I'm just going to put in commas just so that we make it. And the units are going to be beats, no more days, and no more days, but this is beats per year. Okay. We should be grateful for our hearts for beating 34 million times a year or so. All right. Now we've been doing this with lots of per hour, per day, per minute. I want to show you that it works for everything. Okay, so big box store, you can fill in the blanks about what you think I'm talking about. Sells a 1.58 bag of chocolate covered peanuts for $17.79. How much do they charge in cents per gram? And so what we can do is we can remember, oh, 1,000 grams is 1 kilogram, kilo meaning 1,000. So 1,000 grams is a kilogram. And of course, 100 pennies is $1, or 100 cents is $1. So the first step I'm going to do is I'm going to write down, what do I want? What are the units that I want? Well, it says, how much do they charge in cents per gram? So I'm going to put cents per gram. Okay, so money is on the top. So let's fill in the money part first. We got $17.79. That's dollars. And on the bottom, there's grams. Well, kilograms and grams, that's both weight. So I'm going to fill this in here. Over 1.58 kilograms. And I could figure this out and get dollars per kilogram. But I don't want dollars per kilogram. I want cents per gram. So let's figure this out here. We want cents on the top. So if we have dollars on the top, we're going to want to multiply by a fraction where dollars are on the bottom. And I know that $1 is the same thing as 100 cents. Does that make sense how I did that? I know that I want to change this dollar. It's on the top. So I'm going to multiply it by something where the dollar is going to be on the bottom so that they cancel out. So $1 is 100 cents. Okay. So now if I did this, I would have cents per kilogram, but I don't want kilogram, I want gram. So if I have kilograms and I want to change this unit, I'm going to put that, this is on the bottom, so I'm going to multiply something where kilograms is on the top. And I know that 1 kilogram is equal to 1,000 grams. Now the kilograms, those units cancel out. And when I do this calculation, I have 17.79 times 100 cents, divide by this, and it's going to give me per gram. So this is what I want. So this is how I would do it in the calculator, is I would say 17.79 times 100. It gives me 1779 divided by, then you could say divide. Let me just think about how I'm going to explain this. I have 17.79 times 100, and in my calculator, I'm going to say, oops, didn't quite work, divided by 1.58, and then and then I hit my answer, and then I'm going to divide it by 1,000 again. So I'm going to go 17.79 times 100 equals something, divided by 1.58 equals something, and I'm going to divide it again because it's on the bottom. I have to divide it, right? Divide by 1,000. So let's see what I get here. Divide by 1.58 and then divide by 1,000 again. So my answer is, I really want that color that I'm going for here. 1.13 cents per gram. Okay, this is about as hard as I'm going to get the questions for sure. And then I will definitely go over this one again. Let me keep moving on for a few minutes, and maybe there's another one that will make more sense because we're going to do a bunch of these ones. So the second part of the question is, and I did this actually as an experiment, and I feel terrible because I just ate 1.58 kilograms of chocolate covered peanuts. If each M&M weighs 21 grams, how much cents per M&M? So I'm going to make a comparison. I'm going to say one M&M is the same thing as 21 grams. And I'm probably going to use this as my fraction that I'm going to multiply by. So I have what do I want first? I want cents per M&M. So I have 1.13 cents per gram. Cents and cents are the same. I don't have to change that at all, but I need to change grams and M&Ms. Because I have grams on the bottom, I'm going to put these grams on the top. So I say 21 grams per 1 M&M. Grams and grams cancel out. And now it's 1.13 times 21 divided by 1, but you don't need to do that. So times 21, and it gives me roughly 23.6 cents per M&M. There you go. So next time you have a big bag of M&Ms, know that each one of the M&Ms costs you about $1/4 to eat. Whew. Crazy. Okay, I'm going to just pause for about half a minute here. Shake your head. Do a bit of a stretch. We're going to switch gears, I think. Oh yeah, we're going to switch gears. And then what I'm going to do is I can certainly go back over these questions, or I can give you a bunch more of these type of questions, or I can certainly give you a hand when you go to write the test. And just wait another maybe 30 seconds. Have a coffee if you need it. An M&M would have gone so perfect with that coffee. All right. All right. All right, I'm going to be switching back and forth here a little bit because the next page, page 5, my goodness, we've gone through page 5 already. No, that can't be right. Did I miss a page? Page 4, page 2. What happened to my page 3? Did I seriously miss a page? We just skipped to the hard stuff. Just give me a second. I got to figure out why this is happening. I did skip page 3. Let me quickly go and find my notes, and excuse me while I stumble through this presentation here. Okay, 1, 2. Oh, you see, now this makes so much more sense because I was supposed to go through the easy ones first. All right, I'm just gonna take a screenshot of this and we'll make it happen here. Whoops, sorry again for this. All right, so this is page 3. We're going to go through and finish this up here. That was mean. It seemed to me that we were really racing through this material. All right, so we're going to go back a step or two. Thank goodness. This is why they're just, it feels like it's going at lightning speed because we skipped all the really good stuff. So how fast in kilometers per hour is a jet if it takes 3.5 hours to travel this many kilometers? So the first step, we're going to write what are the units that we want. Wow, my pen is really big there. Okay, so we want kilometers per hour. That's what we're asking for. So let's put kilometers in the top, which is 4340 kilometers, and divide that by hours. It takes 3.5 hours. All right, so 4340, I'm doing it on my calculator, divided by 3.5. It's 1,240 kilometers per hour. And again, if you do it this method, you know what you want, you see kilometers, hours, you're not going to mix them up. It's going to be really straightforward. This is why I love this system. All right, let's do number 2. How many donuts are in each box if there's 72 donuts in 8 boxes? Oh my gosh, I must be food obsessed. I'm starving already. All right, let's do it. We want to know donuts per box, so I'm going to write the units, what I want. Donuts per box. Okay, so let's put donuts in the top. There's 72 donuts. I don't know if that's not the spelling, but that's all right. And 8 boxes, because box is on the bottom. Okay, and we're going to go 72 divided by 8, which is going to give me 9 donuts per box. Okay, these are way better. This is way more appropriate. Okay, and then using this answer, how many donuts are in 2 boxes? Well, we know that if there's 9 donuts in 1 box, then there's got to be double that in 2 boxes. But how do we know that? And I'm going to show you a way to do this, because what we're going to do is we're going to do it way harder. In our heads, we could figure this out quickly, and that's no problem. But once we get up to 12 boxes or 12 3/4 boxes, I just can't do that math in my head. I want a way of doing it. So I just want to use this example to show you a way of doing it. So how many donuts are in 2 boxes? Well, I know there are 9 donuts in 1 box. I'm going to, because box is on the bottom, I'm going to multiply by the top, and I want to say, how many times 2 boxes? The boxes cancel out, and I'm just left with donuts. Hey, that's what I want, actually. I just want to know how many donuts. I don't want to know how many donuts are in each box in 2 boxes. No, I just want to know how many donuts. So I know I have to multiply by 2. And so I have 9 times 2, which is 18. No units other than donuts, so donuts. And I'm pretty assured that because my units cancel out, I'm just talking about donuts, and that's exactly what I want. So as long as I do my calculation on my computer right, or my calculator right, I'm going to get the answer. How many donuts would be in 12 boxes? Well, you could do the same thing. How many? 9 donuts per box. Box is on the bottom, so I'm going to want to multiply some box on the top of a fraction, but that's fine. And I want to know how many are in 12 boxes. Boxes cancel out, so I have 9 times 12 donuts. 9 is 9108, I think, which sounds like a party to me. Okay, I hope this is making sense to everyone. And again, I really apologize for skipping this page. I didn't intentionally skip it. I like this stuff. All right. Here's question number 3. It costs $12 for a 5-kilogram bag of popcorn kernels. It's a lot of popcorn again. I must be super hungry. How much is this in dollars per kilogram? So I'm going to write the units that I want, dollars per kilogram. All right, let's start. We're going to put dollars on the top. Here's my $12. Cool. There's my dividing line. And I'm going to put kilograms on the bottom. 5 kilograms on the bottom. Okay, this is easy. 12 divided by 5. My units are right. I've got dollars per kilogram. So as long as I do this, then it's 2.4. Or I'll just make it $2.40 per kilogram. Hopefully this is all making sense to everyone. All right, I go to the big box store that I went to for my M&Ms. I see this huge 20 kilogram bag. This is enough to fill a room of popcorn. And it's $45. Is this a better deal? How can we figure it out? Well, let's do the math. What do we want? In order to compare, let's compare similar units. I don't want to compare dollars to kilograms and dollars to grams. That wouldn't help me very much. I want dollars to kilograms to compare to dollars to kilograms. So let's do this again. Let's find out what this one is, dollar per kilogram. So dollars is $45. And it's 20 kilograms on the bottom. And when I do that, I've got the right units, dollars per kilogram. So I'm just going to do it in my calculator, 25 divided by 20. $2.25 per kilogram. And this is where, as a conscientious shopper, you can say, okay, it's a little bit less money, but do I really need 20 kilograms of popcorn? Maybe you do. I don't know. If you have chickens, they'd be really happy. Okay, I'm going to give you maybe 30 seconds here. We'll just quickly look over page 4, and we're going to switch gears now to the volume and the area. Again, if you have any questions about how to do these, especially the stuff on the page 4, these ones, a little bit more difficult for sure, and I'm happy to go over these again. And I really regret having covered these before I did page 3. Again, I'm sorry, that was a goof on my part. Okay, so just so that folks that are taking notes, if you want to write these in there, then that's awesome. Awesome. Okay, so on this next section, there's the last page. We're going to be figuring out calculating areas and volumes of the following shapes using page 1. So I'm going to be flipping back and forth between them. Oh, not that one, this one. Can I move it? No, it's being mean to me. It's back to, there we go. So I'm going to be flipping between here and here to figure out what my formulas are. The first one that I'm going to be dealing with are the area, the surface area of just 2-dimensional shapes right now. And again, I'm probably going to do that about 1,000 times. All right, so let's calculate the area for this triangle. So the thing you need to know about triangles is you need to know the base and you need to know the height. This doesn't help you. These angled ones don't help you as much. It's the height of it and the base. So we're going to look at for the triangle. It doesn't matter what shape. And I can show you why it works. It's pretty cool, actually. But the area to calculate the area is equal to 1/2 times the base times the height. So I'm going to write that in there. Area equals 1/2 times the base. And yes, I'm going to change this pen width because I like it at 12. There we go. Okay, so area is equal to 1/2. Instead of writing base, let's find out what the base is. This is the base, which is 6 meters. And instead of writing height, I'm going to use the height right here, which is 4 meters. So I'm just going to replace height with the number. And in your calculator, you're going to go 1/2, or 1 divided by 2, which is 0.5. 0.5 or 1 divided by 2, either one works. Times 6 times 4. Well, I know 6 times 4 is 24, and half of 24 is 12. But you can do it in the calculator too. So you can do 0.5 times 6 times 4 gives us 12. And the unit is going to be meters times meters, or meters squared. And this is good because we're figuring out what is the surface area, which is a squared unit. Okay, let's go on to the next one here. We have a square that's 5 by 5. So if we look here, rectangle and a square, they're exactly the same. Area is length times width. So I'm going to write that in here. Area equals length times width. Let's call this width. Let's call this length. These are the easiest ones. Length is 5 meters and width is 5 meters. So the area of this shaped square is 25 square meters. Meters times meters, or m squared, meter squared. Okay. A circle. This is where bad jokes can come out. How do you figure out the circle? Area equals pi r squared. Okay, so I'm going to show you that. Just going to write that here. Area is equal to pi r squared. Now, if you have a calculator, you will probably have a pi button on there. And this is the one you should use because it's not 3 or 3. It's close. 3.14159, 26535. Anyways, pi times r squared. What is the radius? Radius means that from the center of here to any point on the outside, that's the radius. If we're talking about a straight line from through the middle, that'll be the diameter. But we're not worried about the diameter so much. We're worried about just half of the diameter, or just the radius. So it's from the center to the outside. So I'm going to rewrite this. But instead of r, I'm going to put in my number, 9 squared. And if you want, what I would do is in your calculator, I would work backwards. So I go 9 squared and go equals, and it'll give us 81, because this is 9 times 9. This is like pi times 9 times 9. And you could do it that way too, but you want to get used to doing it this way. So I'd say 9 squared times pi, and it'll give you your answer. So 9 squared is 81 times pi gives me area is equal to 254.5. And I'm dealing with meters squared. I hope this is making sense. If it's all making sense, I would encourage you to go ahead and get an answer, and as I catch up, just double check your answers. That's probably the best way to do it. Okay, I don't even have to go back because I know this. The surface area of a rectangle is the same formula as the square. This is going to be area equals length times width. If I say this is the width and this is the length, area is equal to 2 meters times 7 meters, which is 14 square meters. Easy peasy. Same with this one now, because I have the formula. Area equals pi r squared. Which doesn't make sense, because cakes are square, pies are round. Anyways, I'm not going to tell my joke. I told myself I wasn't going to do it. Okay, area is equal to pi times, instead of r, I'm going to put in what the radius actually is, which is 7.5. And so in here, I'm going to say pi times, what 7.5 squared is going to be times 56.25 times pi. And I hope that that's going to give me the right answer. Is 176.7 square centimeters. And you know what? I'm not going to be one of those guys, but it's a really good habit to, at the end of these, to make sure that you put in your units. Some teachers are super sticklers about this. And they'll say, okay, you got it wrong. If you don't put the squared centimeters in there, you get it wrong. I'm not going to be a stickler about that, but just remember this is squared centimeters. So when you're looking at an answer and it says, oh, it's squared centimeters, okay, they're talking about surface area. Okay. And we're going to do this rectangle. This is a right-angled area is equal to 1/2 times the base times the height. So area is equal to 1/2 times 8. There's the base. This is my height times 6. And these, of course, are centimeters and centimeters. 1/2 times 8 is 4, times 6 is 24 square centimeters. I'm going to just show you a really quick way of remembering what it is. So if you made this a rectangle that was 6 by 8, you can see that we're only interested in half of this, not this one. So it's going to be half of the whole rectangle. So you could figure out the whole rectangle, which is 6 by 8, which should be 48. We only want half of it, which is 24. That's why they came up with this, this formula. All right, let's go to these more complicated ones, but really they're not that complicated, and I'm going to show you why. Okay. So when we're looking at a rectangular prism or a cube, like a square prism, what we're looking for is we calculate the base, the area of the base, and then we multiply it by the height. So the area of a base is length times width times the height. It's easy. The same thing with a triangle is you figure out the area of a base, which is 1/2 times base times height. We just did that up top there. And then we're going to multiply it by this height. Or a cylinder. We're going to calculate the area of a base, which is pi r squared. We know that from just these ones right here. Right here. So we multiply the pi r squared times whatever the height of the cylinder is. And that's all there is to it for volume. These ones are slightly different, of course, but that's mostly what, and let's look at these last three at the very end. Okay, so the volume for this, let me get my pen back here. Volume is equal to length times width, which is the base, times the height. So height is here, width, and length. So volume is equal to 3 times 4 times 2. 3 times 4 is 12, times 2 is 24. And these are all meters, but it's cubic meters now because we're talking about a volume, a space, not just a two-dimensional, it's three-dimensional, which is why we have the 3 there. All right, let's do this one. I'm interested in figuring out what the surface area of this triangle is and then multiplying it by the height. So volume is going to be 1/2 times the base times the height of this times the height of the other one. And I know that I've got height in there twice. I just can't think of a better word for it. So let's say that this is the base, this is the first height, and this is the big height. Maybe I'll make it a capital H. So 1/2 times 3 times 4 times the height of the whole thing, which is 5. 3 times 4 is 12. Half of 12 is 6. 6 times 5 is 30. I'm just doing this in my head, but definitely use your calculator. And the unit is going to be cubic meters. And it's cubic because it's a volume again. 3 dimensions. That's the easiest way to think about it. Essentially what you need to do is when you see a shape like this, you're going to go to this first page, say, what's the formula? 1/2 base times height times height. Okay, so you write that down in there. 1/2 times base times height times height. And then you just fill in, what I do is I mark what they are. There's the base, there's the small height, there's the big height. And I just fill it in and then I calculate it. That's how I do it. And I like to take steps so I don't make a mistake. Otherwise, I'm likely to take shortcuts and make mistakes. Okay, so on this one, the height is going to be 2 centimeters and the radius is going to be 12. Let's figure out what is this is a really flat, like a birthday cake here. Oops. We're celebrating the last class. I'll put some little frills on it later. Let's go back and see what the formula is. Oh, right. The area of the base is pi r squared times the height. So let's do that. Volume is equal to area of the base, which is pi r squared times the height. Height is 2, radius is 12. Cool, so we can do this. Pi times 12 squared times 2. I could write another line if I really wanted to. 12 times 12 is 144 times 2. This is where the calculator is going to be handy because I don't know my 3.14 times tables. 144 times 2 is 288 times pi. And the volume of this shape is 904.8 centimeters cubed. It's cubed because it's a volume. Okay, we're on the home stretch, you guys. With 10 minutes to spare. Wow, this is awesome. Okay, here's my tent example. Remember that the volume is figuring out what the surface area of, oh, this isn't a surface. I shouldn't have done this like this. Really, what I want to do is figure out what the surface area of a triangle is, and then multiply it by the 10 feet, 10 inches. This isn't a tent at all. It's tent for ants or something. Okay, enough. I'm getting crazy here, getting towards the end. So I'm just going to write down my formula. 1/2 times the base times the height times the height. Volume is equal to 1/2 times the base times the height times the height. I'm going to make this my big long height. I'm going to make this my triangle. This is my 5. So this is going to be my height. And this is going to be my base. So volume is equal to 1/2 times the base of this triangle is 8. And when I put these dots, it also means just times. It just means that it doesn't get mixed up with x's if I use an x. This height here is the same as this one, so it's going to be 5 times, and then this length or the depth or whatever we want to call it, if you tip that shape up, it would be the height of 10. So volume is equal to 8 times 5 is 40, so half of 40 is 20. 20 times 10 is 200, and I hope I have that right. And cubic inches. Okay, 2 more, you guys. All right. So here we have, I've got an extra reading that I don't really need in here. It also says that the width of this pipe is 2 centimeters. But this would be the diameter, goes from one side right to the other. What I'm worried about here, because this is my formula, I should write my formula. Volume is equal to pi r squared times height. What I want to know is what the radius is. And the radius is from the center out to the edge. And this could be my height, of course. So my volume is going to be pi times my radius of 1 squared, or 1 times 1, that's fine, and times 25. And this is going to be, if I really wanted to get geeky about it, and then I can just type that in my calculator, is 78.5. And what are my units? They're centimeters. And I will definitely come back to these examples if you guys don't understand some of this. And lastly, looks like my desktop computer. And I've got 10 inches by 20 inches by 30 inches. I know that the volume of a cube or of a rectangle, it's going to be length times width times height. So let's write that. Area is equal to length times width times height. This is width, length, height. So I'm going to replace L with the number for length. So area is, instead of L, I'm going to put in 20. Instead of W, I'm going to put in 10. Instead of height, I'm going to put in 30. And that's going to be 200 times 30 is going to be 6,000 square. Sorry, it's not square at all. Cubic inches. I'm just going to leave these up for a minute. Let everyone get started with finishing up their notes. So as you can tell, these aren't the hardest questions. They take a little bit of organization. You find out the formula, you write it down. Then you substitute the numbers into the formula, and then you slowly crunch away using your calculator. You just calculate the numbers, and then you finish with putting the proper units on. Now, I don't have any examples for a right pyramid, which is the area of the base times the height times 1/3, or the circular cone. It's the same thing. It's weird that it works like that, but I love that about math. And I also have a sphere, but you know what? If given the radius of this sphere, you could replace the r with whatever the radius is and calculate this. This would be 4 times pi times r cubed divided by 3, or 4 divided by 3 times pi times r cubed. Okay, so it's at this point that I'm 4 minutes early. This is a record for me. I'm finally figuring this thing out. I'm going to stick around. So if you want to work on your chapter 5 and 6 test, you're welcome to do that with me if you're happy to work on this on your own. Awesome. You've just finished the basics of Math 8. And I wish you really the best luck next year. I really want to just talk for 1 second about this. If you're going back into a brick and mortar school, or if you're joining us here, what I want you guys to do is advocate for yourself. So go in to your math teacher and say, you know what, I get a lot of help using a calculator, and I can do the math. It just takes me that much longer to do. And so I really value this. Most math teachers are very reasonable people. We're not typically mean. And we say, okay, I understand that. I'll just make a note of that, but this is no problem. And then you'll actually be able to use some of the tools that I've showed you, some of the calculations. Certainly that fraction button is an awesome one for future math, and you'll be able to use that and advocate for yourself. Also, just know that math is awesome, because if you break it down into small little tasks, Most math is quite doable. It's just sometimes it involves 5 or 6 different steps when you get really complicated problems. But as you can see, if you write it all down, you can keep track of all those steps and just be meticulous. Just watch to make sure all the negatives are negatives, all the positives are positives, and you'll do awesome in math, and you'll flourish. I really, truly believe this. So if you are happy to go on your own and finish the test on your own, submit it the same you would normally. What I'm going to do is I'm going to put out a note to all your teachers if I'm not your teacher, and they will contact you at some point and say, okay, this is great that you've done this, and you'll be done for the year in terms of math. You'll have covered the basics. And you can just concentrate on finishing up all your other subjects. What I'm going to do right now is I know that I will look through the chat here for a few minutes and start answering questions based on the notes, if you want me to go over the notes again. I know there's that one section where I skipped ahead, so I might redo those quickly. I also want to just quickly go through the test here and sort of identify. This is a nice way of doing this is often when I look at a test or when I've got a quiz in front of me, I just like to go through and say, oh yeah, I've got an approach. Yesterday I typed 126 words in 2 minutes. How fast can I type in words per minute? So I'm going to write words per minute as the unit, and I'm going to fill in the top and the bottom, words on the top, minute on the bottom, do my division, I'm done. The same thing with this. An employee makes $146 in a 7.5 hour shift. How much does it make in dollars per hour? So I'm going to write dollars per hour is what I want. And you're going to put dollars on the top, and you're going to put hours in the bottom. This one, which of the following cars is most fuel efficient? You get to decide whether it should be kilometers per liter or liters per kilometer. You can do either, but you have to think about it. Which is more efficient? Would it go farther on 1 liter, or would it take less fuel to go the same amount of kilometers? You think about that, and you're just going to do a comparison. You can do the hybrid versus the smart car and figure it out. Here, it's Usain Bolt. He ran 100 meters in 9.58 seconds, just so fast. We must all remember that. How fast is that in kilometers per hour? So that's where we're converting units. We're going from 100 meters. How many meters are in a kilometer? And we'll do the conversion. I'm certainly happy to help there. And the last page is very similar to the last page we just did in the notes. Here's a rectangle, triangle, circle, and another circle. A prism that's triangular prism, my soup can, which is a cylinder, and I got a 2x4. And I think you even have a bonus mark, so you can get more than 100% on this test if you want. So what I'm going to do is I'm going to start asking. So I'm going to go over page 2 and page 4 again, and I might just go through and start on page 1 and really cover quickly because there's a few people who came late to the session. Okay, and thank you everyone again for showing up. This is awesome. So page 1 is essentially just formulas. There's nothing that I had to do here. It's just like a reference. Yeah, thanks again, guys, for coming. So page 1 is just formulas, and it's just for that last page of the notes. And you can certainly use this page of formulas to finish your test as well. So page 2, I just want to quickly go over. So a unit rate is some amount of something per or divided by 1 unit of something else. So when we're talking 30 kilometers per hour, we never say, oh, I got caught speeding because I was doing 62 kilometers per 400 hours or 20 hours. You would say always it's per 1 hour or per 1 minute or per 1 minute or per year or whatever it is. So the second number, when you do the division, it's so many kilometers per 1 hour, or And we'll see that again. So a unit rate, or a rate, is 30 kilometers divided by 1 hour, or 30 kilometers per 1 hour. 33.5 revolutions per minute for a record player. Or I was at a hot dog eating contest and the rate was 5 hot dogs per minute. That's really gross. I'm not that hungry anymore. And so in real life, we don't often measure things in just 1 minute. Sometimes we do, but often, you know, if we're driving, for instance, we drive 580 kilometers in 6 hours. We're like, what was our average speed? This is good. Or I like to run and I want to find out how fast I'm running. This is sort of what I do, is I run, you know, 8 kilometers in 47 minutes, and I figure out exactly what the unit is or how fast I'm going. So the first step in figuring these out is state what you want. So in this question, when it says, what if it takes us 6 hours of driving to cover 580 kilometers, how fast is it in kilometers per hour? So I'm going to state, I want to state what it is that, what is the unit that I want in the end? So state what you want, kilometers per hour. That's what I want. It's just asking for that. And absolutely, I'll help you guys out with question 1 here in a moment. This is actually the same thing as this one. Essentially, state what you want. In question 1, state what you want. What are the units that you want? Then what you're going to do is you're going to pick through the word problem and say, okay, I want kilometers on the top of the fraction. So let's figure out where it is in there. Oh, there's kilometers on. So that's what I want to do. I want to figure out, I'm going to put kilometers on the top. So I'm going to put 580 here on the top of the division or the fraction, either one. The line for the fraction, or the per, you know, kilometers per hour, it's the same thing as the divide, or the bottom divide by under the fraction. And on the bottom, I want to put hours. So how many hours? Oh, 6 hours. So I'm going to replace this. I'm going to put 6 hours in the bottom. Now that my units are right, I have kilometers per hour. I know that I can just do a quick division. So I'm going to say 580 divided by 6. 580 divided by 6 is 95. And I'm just going to put my units, kilometers per hour. I'm going to show you another example here. So poor Canucks captain, in the last 5 games, served 28 penalty minutes. What was his average penalty minutes per game? So this is what I want. I want penalty minutes per game. So I'm going to put that there. And I'm going to fill in the blanks. It's like, how many penalty minutes did they get? Captain got 28 penalty minutes. So I'm going to put 28 on the top of the fraction. And how many games? Oh, in the last 5 games. So I'm going to put that on the bottom. So I know that my units are penalty minutes per game. So I'm just going to do a quick division. 28 divided by 5 is 5.6. And I know my units, penalty minutes per game. I'm done. Yeah, that'll work. How fast in kilometers per hour is a jet if it takes 3.5 hours to travel 4,300 kilometers? This is takeoff and in the air and all the rest. This is a fast jet, I think, actually. So I'm going to put what I want, my units of what I want, kilometers per hour. Now that I have that, I'm going to put on the top of the fraction, here's my fraction line, I'm going to put the kilometers. So I'm going to take that kilometers, I'm going to put it on top. Oops, that's not going to give me enough pen. Stop. Sorry, I just have to fix my pen here. Close enough. So I'm going to take my kilometers on the top because that's what it's asking for. So I put my 4340 kilometers. And on the bottom, I want my hours, which is 3.5. So I put that on the bottom. My units are now kilometers per hour, so I can just do the division. 4340 divided by 3.5 gives me 1,240. And my units are kilometers per hour. Perfect. Same thing about this one. How many donuts are in each box? There's 72 donuts in 8 boxes. So I want to know how many donuts per box. That's my unit that I want. Now I'm going to fill it in. How many donuts are there? There's 72 donuts. So I put that on the top. 8 boxes, I put that on the bottom. My unit is donuts per box. Donuts per box, that's perfect. And so I just do the division. 72 divided by 8 gives me 9. Now, it says how many donuts are in 2 boxes. So I'm going to put, this is how many I have. I have 9 donuts per box. Because box is on the bottom, I'm going to put box, I'm going to multiply it by the 2 boxes on the top so that the units cancel out. You could do that if you wanted. Box cancel out with box. I'm left with 9 times 2 is 18 donuts on the top, no units on the bottom, and that's perfect. I want 18 donuts. That's what I wanted, actually. Yes, first 2 questions of the quiz. All right, and the same thing for this. I'm going to come right back to this because I'm not sure that anyone's actually needing this. I'm happy to cover these again. I think that you understand how I go about it, and we can certainly look at this page later if you want. Let's look at the chapter 5-6 test. So yesterday I typed a 126-word essay in exactly 2 minutes. It was really fast for me, actually. How fast can I type in words per minute? So I'm going to underline that, not circle it. Just a minute.